Well, believe it or not, we're already on to our sixth unit of the year. Um, this unit is all about calculating with something called a mole. I've affectionately titled it an introduction to stoichiometry, and you will learn much more about stoichiometry in the next unit. But to calculate with moles, we first need to understand what a mole is. A mole is basically a quantity. It is a quantity of things. It is abbreviated as MOL, which I know is kind of silly because all I did was drop off an E, but that's how you abbreviate it, MOL, or the full spelling is MOLE. Now, this quantity that I'm referring to is a astronomically large number, 600 or 6.022 times 10 to the 23rd. Times 10 to the 23rd means there are 23 zeros. It is absolutely massive. We use these numbers that are so big in chemistry because, again, atoms are very small, or we're talking about a large amount of a substance which has a large number of atoms in it. So sometimes dealing with really big numbers can be difficult, so we just convert it into something called a mole. Um, so the molar mass is something we're going to have to learn how to calculate, and that's one of the first steps we're going to do is to calculate molar mass. Now, the mass of 1 mole, or molar mass, is basically the average atomic mass. Okay, so what I mean by that, to translate that into regular English, I have a periodic table here. If I look right here, there's the average atomic mass for silicon. The average atomic mass, that is the mass right there, in this case 28.086. That is the mass of 1 mole of silicon atoms. Or to rephrase that, if I had 6.022 times 10 to the 23rd atoms of silicon, it would weigh exactly 28.086 grams. So that is the average mass, and that is the mass of 1 mole of silicon. And it's the exact same thing for every other element. If I had chromium, 1 mole of chromium, 6.022 times 10 to the 23rd atoms of chromium, it would weigh 51.996 grams. That's how much it would weigh. All right, so yeah, and so like it says here, unit is some number of grams equals 1 mole. Again, it's the average atomic mass right off the periodic table, okay? So to find that molar mass of a compound, you would add up all the individual masses of the compound and use the periodic table, of course, because I just had it in my hand, to find their individual masses, okay? So to show you what I mean, it says calculate the molar mass of the following. The very first one is copper. Now, copper is located right here, element Cu, and it is 63.546. So it would be 63 point, what did I just say? 546 grams. That's the mass, the weight of 1 mole of copper, or again, 6.022 times 10 to the 23rd atoms of copper. All right, chlorine is the same thing here. So chlorine is, looking at my periodic table, it says 35.453, but notice it's Cl2, so I'm gonna have to multiply that by 2. And I did not bring my calculator, that was not very smart. So I'd have to multiply that by 2. Hold that thought, guys. All right, I just got my calculator, so let me go ahead and calculate that. That would be 35.453 multiplied by 2 because there's 2 chlorine atoms. My total mass of chlorine gas would be 70.906 grams. That's the answer right there. H2O, again, we have 2 H's and 1 O. So my hydrogen, the mass of hydrogen is 1.008. There are 2 of them. My mass of oxygen is going to be 15.999 times 1. So that's obviously going to be 15.999. I guess I didn't really need to do that, did I? And this would be 2.016. I'm going to add those two together to find the molar mass of water. And 15.999 plus 2.016 is 18.015. I could have done that in my head, right? Oh well. That's the molar mass of water. So if I had 6.022 times 10 to the 23rd molecules of water sitting in a container, it would weigh 18.015 grams. All right. So here's some other ones. Let's go ahead and try these really quickly. So for sodium sulfate, we have a sodium atom, we have sulfur, and we have oxygen, right? So my sodium, if I look at my trusty periodic table right here, 22.990, 22.990, there are two of them. Then my sulfur is 32.066. There's only one of those. And then oxygen is 15.999. And there's four of those. Okay, let's go ahead and calculate those out real quick. So we have 22.990 times 2. That is going to be, just for the sodiums alone, 45.98. For the sulfurs, obviously, 32.066. And then my oxygen, 15.999 times 4 is 63.996. I'm going to add those all together to get my molar mass of sodium sulfate. So that plus 32.066 plus 45.98 is 142.042 grams. The unit is always going to be a gram. Now, the reason why I'm adding from the bottom up is because I left the 63.996 in my calculator. I didn't clear it and then have to retype it in. So since I already had it as an answer, I just went ahead and added the two numbers above it. Just a little shortcut, if you will. All right, calcium phosphate. Calcium, I'm going to go ahead and do this over here because we need a little more space. Calcium, phosphorus, and oxygen. Now, you might be thinking, wait a minute, we're not supposed to break apart the polyatomic ions like sulfate and phosphate. Well, to find the molar mass, you kind of need to. You could memorize that a sulfate has this mass and a phosphate has that mass. I mean, you're going to see it right here again, right? But I don't have those memorized. So I'm just going to do this the long way. So calcium is 40.078. Phosphorus, again, is 30.974. Oxygen is 15.999. And we're going to multiply by how many there are. So there are 3 calciums, there are 2 phosphoruses, and there are 8 oxygens. Remember, that little 2 right there gets factored to the 4 of the oxygen and to the phosphorus, but not to the calcium because the calcium is not inside the parentheses. All right, let's try this again. 40.078 times 2, times 3. Oh, let me just try that all over again. Sorry, guys. 40.078 times 3 this time. That's going to give me 120.234. Then the next one, 30.974 times 2. It's going to give me 61.948. Sorry, my sloppy handwriting there. Times 8. This one's going to be 127.992. Add them all together. So I have the bottom one already in my calculator stored. I'm going to add the next one, 61.948. And 120.234. The total mass of calcium phosphate, or at least 1 mole of it, is 310.174 grams. That's how much 6.02 times 10 to the 23rd number of calcium phosphate atoms would weigh. Okay, the next one, we have calcium disulfide. Let me erase this real quick. Calcium disulfide, or excuse me, sorry guys, sulfur dioxide. Sulfur is S, dioxide is O2, so SO2. So we have S and we have O, sulfur dioxide. Sulfur, of course, is 32.066. There's only one of those. Oxygen is 15.999 times 2. All right, so 15.999 times 2 is 31.998. want to add that to this one, 32.066. I already have it in my calculator, so I'm going to add 32.066, and that gives me a grand total of 64.064 grams. Okay, oxygen in the middle. Oh my gosh, I'm going to have space here. Let me change my colors. My oxygen, of course, as you guys know, is O2. O is 15.999 times 2, which we have already found is 31.98 grams. That's the molar mass of oxygen, or 2 O's. The next one is aluminum oxide. Aluminum oxide would be Al. Oxide is 2. Oxide has a -2. Aluminum has a +3. So that'd be a 3 there, and that'd be a 2 there. Al2O3 is aluminum oxide. Now that we know that, we have aluminum and we have oxygen. Aluminum is 27. It rounds up 27. 26.982. There are 2 of them. Oxygen is, again, 15.999. There are 3 of those. We already know what 3 oxygen is. I saw it somewhere. Nope, we did 2, 4, and 8. Wow, okay. Well, let's find it. So 26.982 times 2 is, and no, there is no short way of doing this, guys, 52.964. That's supposed to be a 4, but my pen's messing up. And then I'm going to do 15.999 times 3, which is 47.997. Add those two together, and what I get is 2.964, 100.961 grams. Okay, that's the molar mass of aluminum oxide. The next one we have is potassium phosphate. Potassium is K. It is a +1 charge. Phosphate is PO4 with a -3 charge. So that 3 would go there. The 1 would go there. So I do not need parentheses. So it's K3PO4. All right. Now that I know what potassium phosphate is, we have potassium, we have phosphorus, and we have oxygen. Potassium, again, is 39.098. There are 3 of those. Phosphorus, again, is 30.974. There are just 1 of those. And oxygen, again, oops, wow. Let's try it again, 15.999 times 4. 15.99 times 4. Didn't we do that one already? Yes, we did. It is, I see it right here, it is 63.996. Okay, then we need our phosphorus times 1, which of course is just 30.974. And then we need our potassium times 3. So 39.098 times 3 equals 117.294. If I add those up together, plus 30.974 plus 63.996 equals 212.264 grams. So that's how you do the molar mass. I'm running out of room, so you guys could figure out iron 3 sulfide on your own. What I will give you is the formula for iron 3 sulfide, which I'm sure you guys should know is Fe. Sulfide is S, so that'd be a 2, and that'd be a 3. That's iron 3 sulfide. So again, just to recap, a molar mass is the mass of 1 mole of an element or a compound. To do that, you use the periodic table. You find their average atomic mass, which represents the mass of 1 mole. If it is a compound, for example, calcium or calcium phosphate, Ca3PO4 parentheses 2, then you just need to multiply the calcium mass times 3, the phosphorus mass times 2, and the oxygen mass times 8, because 4 times 2 is 8. So you just need to be careful with that part. And of course, entering that into the calculator. All right, guys, again, that's the mass of 1 mole. Now, all of this represents a mole. Now, a mole is, again, 6.022 times 10 to the 23rd. It is a massive, massive number, guys. All right, well, thanks for watching. That again is how to calculate molar mass.